Alrighty, good morning, Tigers. This is our very first video for absolute value. We are going to be starting with absolute value equations today, and the next lesson will be on absolute value inequalities. So if you would, just go ahead and take a minute to annotate your learning targets. I'm going to skip that this time just because these are the same learning targets from activities 2 and 3. We're doing the exact same math. We're still creating equations and inequalities and solving equations and inequalities and interpreting solutions. The difference is we are putting absolute value in with it. So there we go. So we will take a second to look at the new vocabulary though. You only have 3 terms that are new: absolute value notation, and absolute value equation. Okay, so prior to watching my video of the lesson, you should have watched a short video on absolute values, and just as a brief reminder of what absolute value is, because you should have covered some of this in 8th grade, or maybe just barely touched on it. It probably didn't go in depth with it, but you should be familiar with the concept of absolute value. But if not, if you've never heard of absolute value, you should have already watched a video on it. If you have not watched that video, go ahead and pause this video and pull the other video up. It will be either on your Google Classroom or linked to however we're setting this up, because remember, I'm filming these ahead of time, but it should be on your Google Classroom or our school website or our Algebra 1 website. And if you're watching me on YouTube, it's in the Unit 1 videos, or Unit 1 playlist. So, yeah, so if you haven't done that, go ahead and do that. Okay, but what we're going to do, so assuming you've watched this video, we're going to go ahead and start with task 1. Okay, so task 1, understanding absolute value. Mr. Robkin is preparing the school marching band for the homecoming halftime show. He has the first row of band members stand in positions along a number line on the floor of the band room. The students' positions match the points on the number line shown. Okay, so use the number line to write each student's distance from 0 next to their name. For example, Tanya is 2 units away from 0. Israel's distance is also 2 units away from 0, even though he is at -2. So if we look, Laura is at 0, right? If I want to know Tanya's position, she is at 2. Well, that's 2 units away from 0. Israel is at -2. So if I were to count that, that's 2 units away from 0. So I would like, if you would please try if you would do number 1 on your own, please. Just recording how far away from 0 each person is. So go ahead, try that, and pause the video. Okay, so here is what I came up with. So if we look, Derek is at -7. That is 7 units away from 0. Kia is 5 units away from 0. Antoine is 3 units away from 0. Sam is 6. Laura is 0 away from 0 because she's standing directly on 0, so her distance is 0. Mara is 3 units away. Nick is 5 units away. All right, so let's see, what are some things you notice about all of these numbers? And I hope that you notice that all the distances are positive. And if you think about it, if you measure distance, it should always be positive. So since the reason we're filming these videos is because of COVID-19, let's go ahead and address it. Social distancing. Everybody should be 6 feet apart. Is there any way for you to be, we're told that you should not be less than 6 feet apart. So if I told you to stand -6 feet apart, does that make sense? Well, no, because first off, that's a violation because that's less than 6 feet, but can you measure -6 feet? I've had people say, well, you know, if we're 6 feet apart this way, or this way, that might look better. If I move to the other side, then we're negative 6 feet apart. Well, no, you're still 6 feet apart. It doesn't matter. We're just, all distance and all feet apart should be positive. So this is when we get into absolute value. So the absolute value of a number is the distance from 0 to that number on a number line. And just so we know, distance is always positive, which we just said, but I'm just rewriting that. Distance is always positive. So since absolute value measures distance, and distance is always positive, that means absolute value is always positive. So when you take the absolute value of a number, you end up with the positive distance. Okay, so then we have absolute value notation. So we haven't really talked about notation too much. As you get further and further into math, notation is just a way of writing things. We'll get into function notation in the next unit, and I'm trying to think of some other things that we've written, like when we've done in the last, let's see, in literal equations, we had a variable that was v sub 0. This is subscript notation. And notation just means a fancy way of writing something. So absolute value notation is a way of writing absolute value. Absolute value notation is these two bars. So if you see x in these two bars, or if you see a number or an expression, that means that we're taking the absolute value of whatever's in here. So when you see this, this is the absolute value of x. So this is absolute value notation. That's just how you write it. Okay, so Tanya's distance is the absolute value of 2. Israel's distance is the absolute value of negative 2. And since they're both 2 units away from 0, we can say that Tanya's distance equals 2 and Israel's distance equals 2. Even though their distance, one of them's positive and one of them's negative because of where they're at. They're on opposite sides of 0. But the absolute value, their distance, is still 2. Okay, so what I want you to do is I want you to try number 2. You're just writing their distances in absolute value notation. So I'll do Derek with you, and you can do the rest of them. So Derek is at negative 7. So his distance would be whatever the absolute value of negative 7 is. And because it's an absolute value, we're measuring the distance, well, negative 7 should be 7 units away from 0. Okay, so why don't you go ahead and pause the video and you try number 2 on your own. Okay, so you can see what I've written here. Basically, you just put their where they're at on the number line in absolute value bars. Their distance is positive, though. So the absolute value of each number yields a positive number. So absolute value of negative 3 is 3. Absolute value of positive 5 is 5. Doesn't matter what it is on the inside, the absolute value bars make it positive. All right, so task 2, we're going to work through the majority of task 2 together. So we just kind of wrapped our brains around what absolute value is. Now we're moving on to absolute value equations. I have your definition for that right here. And an absolute value equation is an equation involving the absolute value of a variable expression. So it's considered an absolute value equation if you have absolute value bars and some variable in there. It doesn't have to be the variable by itself. It could be like an x plus 2 or x squared or something. But as long as you have an equation with the absolute value bars, you're in good shape. Okay. And so we'll get to solving stuff like that. So that's just a quick example. All right. So task 2, absolute value equations can represent distance on a number line. So number 3 asks, which 2 students are 5 units away from 0? So we can look at this one of two ways. We can go to 0, count to 5, and count to -5, or we can look here and look for the two people that have 5 as their distance. And I have Kia, and I have Nick. So Kia and Nick are 5 units away from 0. So let's go ahead and go to the next page. Okay. All right, so A says the location of those two students can be represented by the equation, the absolute value of x equals 5. So explain why this equation represents both students rather than just one. So we are looking for let's not write yet. Let's discuss and then write. Okay, so we're looking for two students who are 5 units away from 0. So this absolute value of x equals 5 is looking for something, the absolute value of something is 5. So something that can go in here will have a distance of 5. So remember, when we take absolute value, we can take absolute value of positive and negative. We can take absolute value of both and yield the positive result. So let's talk about what this means. So the absolute value of x equals 5 means that x is 5 units away from 0. So why does this represent both Nick and Kia and not just one or the other? Both students are 5 units away from 0. Alright, so both students are 5 units away from 0, and this is looking for something 5 units away from 0. There are two possible solutions. Okay, so let's talk about B. B says that you can graph the solutions to the absolute value of x equals 5 on a number line. Graph those solutions and explain why the equation has two solutions instead of just one. Alright, so what can I take the absolute value of to get 5? Well, the absolute value of 5 is 5. So we're going to do this. The absolute value of 5 equals 5. What else can I take the absolute value of and get 5? Well, I can also take the absolute value of -5 and get 5. So x equals 5 and x equals -5 both satisfy the equation. Or both satisfy the equation, absolute value of x equals 5. So I could take the absolute value of both of those numbers and get 5. Both values are 5 units away from 0. All right. Okay, so hopefully that's kind of cementing that, okay, if I've got x in absolute value and I'm looking for, it's x equals 2 or x equals 7, that's how many units away from 0 I'm looking for. All right, so that's great. Do you think we're going to be looking for numbers away from 0 every single time? No, we're not. That would be too easy. I can't do that to y'all. I gotta make y'all think. So we can use absolute value equations to represent distance between between any 2 points on a number line. Let me write that in there. Any 2 points on a number line. So not just the distance from 0, but the distance from any number. So we're going to go back to this band lineup and ask which students are 4 units away from 1. So, and then we'll mark their locations here. So let's go back to the band lineup. So we want 4 students, 4 units away from 1. So we're going to mark, here's 1, put an X there. And we want 4 units away. So let's count. We've got 1, 2, 3, 4, and that's Nick at number 5. So that's 4 units to the right. Let's look at 4 units to the left. 1, 2, 3, 4. And that's Mara, who is at -3. Okay, so let's go ahead and let's put them down over here. So we have Nick and Mara. So we want to, so let's see, Nick was at 5. Mara was at -3. Why? I don't know why I did it 2 different ways. Okay. And just for safekeeping, we wanted them 4 units away from 1. So here's 1, 1, 2, 3, 4. 1, 2, 3, 4. Okay, we're good. So we have Nick and Mara at -3 and 5. Okay, so we want to write an absolute value equation that represents this scenario. So let's talk about what absolute value equations look like, though. We said earlier that absolute value of x equals 5 meant 5 units away from 0. So there's another way we can write this. Normally we write, so let's look at this one. Absolute value of x equals 4 means 4 units away from 0. So we already know this number tells me how many units away. Okay, well, I've been saying how many units away from 0 this whole time, and 0 is not in my equation. But what I can do is I can write it like this. The absolute value of x minus 0 equals 4. 0 is the point we're counting the distance from. Is this equation different from this one? So let's look at this. If I had the absolute value of x minus 0 equals 4, well, what is x minus 0? Well, x minus 0 is just x. So it's the same equation, but we're putting a minus 0 here so we know what we're counting from. Now, do you have to do that every single time that you're solving an equation? No, but this is just kind of visualize where are these numbers coming from. So this is the point we're counting the distance from, and this is our how many units away. Okay. All right, so let me, sorry, I'm OCD. I need to like straighten my papers. Okay, so we're going to move on a little bit. So hopefully this is starting to make a little bit of sense. So, yeah, so, and then just as a formula, we can do x minus, and then this is the number we're counting from, equals the units away. Okay. All right, so the 0 doesn't really affect the x like another number would, but gives us an idea of where we are measuring our distance from. So in item 4, right up here, we were asked to find 2 students that were 4 units away from 1. So we would write that like this. So we're looking for 4 units away from 1. Okay, so what were the 2 possible values for the positions that were 4 units away from 1? Well, Nick was at 5, so 5. Mara was at -3. So 5 and -3 are each 4 units away from 1. Okay, so those two numbers would be our x values. Okay, so what two numbers would x minus 1 be equivalent to? Okay, so these are our two x values. So let's see that. So if I did x minus 1, and we plugged 5 and negative 3 for x, 5 minus 1 would be 4. Negative 3 minus 1 would be negative 4. So x minus 1 would be equal to 4, and x minus 1 could be equal to negative 4. Okay, so hopefully that makes sense. Okay, so since x minus 1 is equivalent to two values, we would have to write and solve two different equations. So write two equations showing what x minus 1 is equivalent to, which is what we just did here. So x minus 1 equals 4, and x minus 1 equals negative 4. So I want you to take a minute and look at this and compare it to this. So we have our absolute value equation that we started with, and we've split it into two separate equations. X minus 1 equals 4 and x minus 1 equals negative 4. So remember, whatever is an absolute value, the absolute value of something is equal to 4. So this something could equal positive 4, or this something could equal negative 4. So when we solve absolute value equations, you're going to pretty much take what's in absolute value and set it equal to both the positive and the negative. Okay, so give yourself, if you need to pause this and take a few notes, go ahead and do that. So go ahead and do that, and then we're going to move on to the next page. Okay. There we go. All right, so let's look at number 8. Number 8 says solve both of the equations you wrote in item 7. So we had x minus 1 equals 4, and x minus 1 equals negative 4. Okay, if I were to solve these, I could add 1 to each side, and I could do it for both equations. And this would give me x equals 5 and x equals negative 3. And those were the two positions on the number line that were 4 units away from 1. Okay, so hopefully this is making some sense. So I would like for you to pause the video and try 9 through 11. You're writing the equation, solving them, and graphing them. So it's 3 different pieces. So make sure, and I harp on this a lot, but if you're taking a test and it asks you to do all 3 things, on the LEAP, you will get points off if you only do part of it. So it does say write an equation, solve it, and graph it. So let me see all 3 pieces, okay? So go ahead, pause the video, and try these on your own. Okay, so I did 9 and 10, and you can check your answers with 11 later, but in case you messed up 9 and 10, I want you to see it. You can use your corrections to help you with 11 if you need to, or if you've got them all right, you can just check it off later. So 2 units away from 0. So since it's 0, I could have put x minus 0 here. Let me do that real quick. But remember, x minus 0 is the same as x, so I don't need to do that. So 2 units away from 0, I would separate it into 2 equations. X equals 2 and x equals negative 2. And since my 2 equations are just x and a number, those are my solutions. So I should have a point at negative 2 and 2, and those are both 2 units away from 0. Number 10, which 2 points are 5 units away from negative 2? So here's where it gets interesting. I'm counting from negative 2. So remember, my formula was x minus whatever I'm counting from. So minus negative 2 becomes positive 2. So this becomes x plus 2 equals 5. And then I split that into 2 equations. X plus 2 equals 5, and x plus 2 equals negative 5. Subtract 2 from each side, I'm left with x equals 3 and x equals negative 7. So when I plot that, I plotted a point at -7 and at +3, and then I put a line at -2 and counted, and that would be 5 units away from each. Okay, so if you haven't done so, go ahead and you need to try number 11. I'm going to go ahead and move on to number 12. And actually, when I say I'm going to move on to number 12, I would like you to try number 12 on your own. I will go over all, I'll go over all 4 of these. So go ahead and give yourself pause the video, give yourself a few minutes, try all 4 of these under number 12. Okay, so here are my solutions to number 12. So first one should have been easy. You can take the absolute value of 10 and -10 and end up with +10. The second one, I think some people are going to struggle with, but this has no solution. Remember, when we do absolute value, we're looking for distance between points, and distance cannot be negative. So here I had the absolute value of something equals -3, and so that's not possible. Now had this been +3, we would have had 2 solutions, but we have one solution because it's not possible. I'm sorry, we have no solutions because it's not possible. You can't have the absolute value equal and negative. Okay, so third one, split it into 2. X plus 2 equals 7. X plus 2 equals -7. You can subtract 2 from either side, get 5 and -9. Here we have 2x minus 1 equals 5 and 2x minus 1 equals -5. Add 1 to each side, divide each side by 2. You would end up with x equals 3 and x equals -2. All right. So we're going to move on to the next section. Now I'm reading this and I'm realizing I wasn't supposed to tell you to just go ahead and set them equal to the positive and the negative. It's supposed to be, oh, you discover that on your own. And I think we kind of did work through that together, even though I'm in a room by myself. That's kind of weird. And this is where you get into, hey, these 2 points can be solved by setting it equal to 2 equations. So that's what we're going to do. I'm just going to work these 2 with you real quick. So we have x minus 3 equals 7 and x minus 3 equals -7. So just to quickly solve these, we're going to add 3 to each side. And we have x equals 10 and x equals -4. So something I remember when we talked about solving equations for the first time, and I told you there's no reason to get these wrong because you can always check it. And that's still true for here. So just as a refresher, let's check these 2 solutions. So we have the absolute value of 10 minus 3 equals 7, and we have the absolute value of -4 minus 3 equals 7. 10 minus 3 is 7, and the absolute value of 7 is 7. And -4 minus 3 is -7, and the absolute value of -7 is 7. So both of those are true, so my solutions are correct. I just wanted to refresh you that, hey, you can still do that. All right, so let's look at this next one, and we have some absolute value and distributive property, or a number on the outside of absolute value. So I've got some advice here. And this is not hard and fast, this is the only way to do it, but this is kind of my theory on it. I try to divide instead of distribute. I don't like distributing inside absolute value. And the reason being is that if you have a negative number on the outside, you can't distribute. So in absolute value, and I'm going to put NAV for absolute value, you cannot distribute a negative. And that's because the negative doesn't really matter inside here, but it does affect your answer here. So you can't distribute your negative because those absolute value bars can't screw with your signs. So you cannot distribute a negative in absolute value. So what I do is, instead of worrying, okay, can I distribute that or can I not distribute that? I just get rid of this part and I just tell myself you cannot distribute. So yes, you can distribute a positive, but I don't want you to confuse yourself and try to distribute positives and don't distribute negatives and stuff. So I just tell you don't distribute. Now, a lot of people don't like this, but this can work in your favor here. So even though most people want to distribute, you can divide here and make your numbers simpler and make it so much easier to work with. So let's do that. Let's, instead of distribute, let's divide, because this is 6 times whatever's an absolute value. So to undo multiplication, we're going to use division. So the 6's cancel. And you're left with the absolute value of x plus 2 equals, and then 18 divided by 6 is 3. And gosh, isn't that such an easier, nicer, prettier equation to work with? So we'll split that into x plus 2 equals 3 and x plus 2 equals negative 3. Alright, so we can subtract 2 from each side, and that would give me 1, and this would give me negative 5. Okay, and we can check that to see if that worked. So we can do 6 times 1 plus 2 equals 18, and we can do 6 times negative 5 plus 2 equals 18. Okay, 6 times, now the 1 plus 2 is 3, and the absolute value of 3 is 3. And 6 times 3 is 18. And here we have negative 5 plus 2 is negative 3, but the absolute value of negative 3 is also positive 3. And 6 times 3 is 18. Okay. Alrighty, so let's move on to the next page. If you need to jot down notes, pause the video, take care of that. And so we have the back of this, and this is number 13. So I'm going to stop here. Try to do some of 13 on your own. We will answer questions on this the next time we see you. So try to get as much of that done on your own as possible. Remember, practice, practice, practice. And but if you have any questions, feel free to mark it, and we'll talk about this the next time we see you in class. Or if we're going to be, you know, again, I'm filming these in advance, so who knows, this might end up on a weekend where, you know, one group's in 2 days in a row or something. So if you can't wait, you can always email or drop a comment or put something in Google Classroom, contact us, and we will get back to you. But in the meantime, like if you have a question that can wait till you see us in class, just mark it and ask us when we get back in class. So make sure you take care of this. Make sure you are taking care of your homework assignment or your practice assignments. And make sure you're taking care of your spiral review too, guys, because all of those are super important and will help you out so much when we get to the unit test, which should be coming up pretty soon. We have one more quiz, and then we have our unit test. So thank you so much for your attention. I hope you guys have a great afternoon.